So my name is Antonio Franchi. Thank you very much for the introduction. And first of all, I would like to thank the University of Rome for inviting the European Space Agency today and the Italian Space Agency and all the organizers. It's a great pleasure for me to be back. I'm Italian. I'm actually from Rome. I almost studied in this university, but then I ended up studying the University of Rome, which is the number one University of Rome, which is the other one. I've been living abroad for about 28 years, so it's a great pleasure to be back today here in Rome, my home city, to give this talk. Of course, I have a very challenging job to follow the excellent lecture of Professor Ghilembi, and also try to fit in the shoes of my director, Magali, which was the presenter which was supposed to be here today, but unfortunately she apologizes for not being able to be present. Also, I'm conscious that I'm the only thing left between you and your lunch this morning, so it's a very challenging job to try to keep the attention for the next half an hour, so I'll try and do my best. At the European Space Agency, we do many things related to space, and where I work is in the Directorate of Telecommunications, so satellite telecommunications. And I will today try to address one of the topics, and today I want to talk about 5G and the importance of satellite in 5G. One thing I would like to say from the outset that satellite is a very efficient way of delivering 5G services, following straight from the previous lecture. Just at a show of hand, how many of you have heard about 5G before? Can you please raise your hand if you have heard about 5G before? So that's great. So that's pretty much everyone. How many of you know what is 5G? How many of you know, I'm not going to ask you, but just please raise your hand. How many of you know what is 5G? See, that's interesting because everywhere we go in talk about 5G, everybody we ask to, we get a different answer because 5G is such a huge phenomenon, a huge revolution, as Michele mentioned before, that whoever you ask to, you receive a different answer what 5G is. And I guess the third and last question, how many of you know about what satellite can do in 5G? 2 people in the room. So that's the reason I'm here. The reason I'm here, I'm trying to promote the role of satellite in 5G. That's one of one of my main mission in ESA and one of the mission of our group, which is called Future Projects. We believe that satellite has a big role to play in 5G, and hopefully after today's talk, you'll agree with me. So mainly I'd like for you to take away 4 key messages from this speech today. The first one is a little bit of what 5G is. I would like to come out of this room today where we kind of agree a little bit what 5G is. 5G is a lot of different things for a lot of different people. It can be defined as a standard, can be defined as an ITU 3GPP specification, but it also can be defined as much more than that. As Michele mentioned in the opening session, just like the internet, 5G can be defined as a set of services and applications very, very close to people and to the industry that utilizes a lot of standards, but actually utilizes a plethora of different standards, a different set of networks, or perhaps network or networks. But the important thing is what we deliver to the user. So that's the first message I would like to cover with my talk. The second message, of course, the satellite is highly complementary to the terrestrial 5G deployment. We heard before 5G deployment is going to be challenging. It's going to be mainly concentrated in a highly densely populated area, and there's going to be a cell densification within the big cities. What satellite can do is complement this and actually make sure the satellite is a global success, rather than perhaps a city-to-city success. So that's the second message. Of course, the third message, besides helping to the socio-economic impact of 5G in the world, 5G actually in itself has a number of attributes satellite has a number of attributes that help 5G in delivering better security, better resilience, and certainly better coverage, global coverage, that is going to be very, very challenging just by the deployment of single terrestrial 5G. Finally, I'd like to tell you a little bit of what we, European Space Agency, is doing in this quest to promote satellite even from today in the delivery of integrated 5G services, and how we are helping the industry, the European, Canadian, but international industry in general, and how we are establishing global cooperation agreements with national and international institutions about 5G. I hope the next agreement will be with the Città di Roma, as we were talking this morning with the assessor from Rome. Before talking about 5G, though, we need to realize, and I think this is the perfect forum, that what is in act today, there's a digital transformation, digitalization of the industry. People talk about Industry 4.0 or the new industry, and there is a pervasive digitalization in everything we do, everything we act upon, and every element of the industry that we look at. The business is going to be profoundly transformed in the next few years due to this digitalization of the industry. And of course, connectivity is the enabler of this digital transformation. Connectivity is at the core of this digitalization. It's a profound enabler which will be present as a connectivity element, as a fabric which allows factories and people to evolve, communicate, and generally perform better and more efficient tasks. I like to refer to the 4 A's or A4, which are the expectations the industry and people has already from now of communication and connectivity anytime, anywhere, globally, with any volume. There's more and more demand for increasing volume, and more importantly, the Internet of Things or the machine-to-machine, anything will be connected in order to enable this digitalization of the industry. So the fundamental attributes of connectivity are ubiquitous. In order to realize this promise where everything, anytime, anywhere, you need to have communications everywhere. This morning was mentioned a couple of times that there's this expectation that communication will be ubiquitous everywhere, and 5G actually confirms this expectation, saying that communication will be available in large volume, high throughput, everywhere. So connectivity is becoming a commodity, and there's a huge expectation in the public and in the industry that will be available at any time. So that's where 5G fits in. So what is 5G? 5G is everything we said above, and it's an enabler of the connectivity. It's an enabler of the new Industry 4.0, where the new industry, the new society, the new people will be completely connected. They are already connected from now, but they will be even more connected in the future. So a way of defining 5G, there are many ways of defining 5G, but perhaps the more important question is, what will 5G bring to you? What 5G will bring to the youth? What will 5G bring to the new industry by and large? And here I try to compile a table of the main attributes. There are very different definitions of 5G. There's the famous 5G triangle, which is basically bandwidth, machine-to-machine, and low latency. But perhaps in a more expanded form, there's 6 or 7 attributes which better describe what will 5G bring to society and to users. If you start from the list, for example, obviously the very first promise or expectation is that 5G will bring amazing volume, amazingly fast. So high throughput to everything and everyone. The second attribute is always best connected, which means that not only 5G will deliver very high throughput, but will deliver high throughput everywhere, to everybody. That's a very strong promise that the terrestrial 5G community makes. And people start to expect that. There's a big hype that 5G will be pervasive, will be everywhere. As we heard before, there are challenges for doing that, because the cell densification and the reduction, the move to millimeter wave to deliver 5G will require cells to be deployed much more densely, and that will not only increase cost and energy, but also will increase time to deployment. So there are fundamental economic questions to be answered. How can you at the same time densify a network with increasing cost and time to deploy, while at the same time guaranteed or fulfill the promise of always connected and ubiquitous connectivity? If you go down the list, there are other significant attributes. Energy efficiency is indeed one of the promise of 5G. And the contradiction that was mentioned before is that if you only rely on terrestrial 5G deployment, it's very unlikely, very challenging to meet that energy efficiency promise, as I call it. Satellite can help in all of these attributes. And on the right-hand side, there are the number of applications that perhaps are closer to the users. And that's where users can identify better with what 5G is. What does 5G mean for me? It's not just a standard which I cannot see, I cannot touch, but actually I can relate with the connected car applications which will be enabled by 5G communications. Or I could relate with the virtual reality, pervasive virtual reality in industry and in the houses, which will be enabled by this high throughput connectivity. So in my view, a better way of defining what 5G is get closer to the user and the number of applications which will be enabled by 5G. So from everything I said, the answer 5G is just the 5th generation after 4G. For me, it just doesn't cut it, doesn't really say what 5G is, not just another G. From everything I say, I hope I can try to project the message that I like to define 5G as the fabric which underpin the new society, or the fabric where will help Industry 4.0 to go through this process of digitalization and softwareization, as was defined before. And to do that, there is a connectivity fabric, which is what we tend to refer as 5G. Everything and everybody must be connected, and 5G will deliver that. And my argument and our argument is that satellite must be an integral part of 5G in order to fulfill, to help deliver the 5G promises. So satellite is going to be a key element for fast deployment of 5G services. Even today, a lot of the satellite application and most of the satellite operators actually do deliver a lot of the services and the applications that I showed in the slide before. Satellite is the only way to provide ubiquitous coverage, ubiquitous global communications, if you like. Not only that, but there is an inherent resilience built into satellite, which doesn't rely on terrestrial deployment. It doesn't rely on problem occurring on Earth, but could reach user directly via satellite. The high speed and low latency is something that is being addressed, and the evolution of satellites is a testament that the satellite integration with terrestrial communication is already happening today. No doubt you will be aware that besides the large constellation of geostationary satellites, there are a number of low Earth orbit or non-geostationary constellations being built, some already launched and operational, and many promising to launch hundreds or thousands of satellites in the next few years in lower orbit, which will improve not only the speed of delivery of communication, but also the latency. We fundamentally reduce the latency by operating at lower orbit. So to show a little bit more the integration of satellite and terrestrial 5G communications and how satellite can help in that, I'd like to show you a very short video. It's about 2.5 minutes, which will hopefully reinforce the points I was just trying to make in terms of complementarity and integration and augmentation of satellite and terrestrial 5G communication. Let's see if the video works.
Being connected is everything. Both visibly and invisibly, connectivity keeps us learning, moving, communicating, and safe. A revolution in connectivity is coming as the new generation of wireless communication, 5G, moves us closer to being connected to everything, everywhere, at all times. 5G enables the seamless interworking of different technologies and networks at speeds and performance that no previous generation has been able to touch. With 5G, your mobile phone, home, car, and even your city can all be connected sharing information and responding to commands instantly, regardless of when or where the command is made or how much data it requires. 5G means downloading a film in seconds while on the go. It means a world where the logistics of industry manage themselves. It means being connected everywhere, all the time, immediately and securely. But no system is perfect. To support these applications, 5G will need uninterrupted coverage at unprecedented capacity, which terrestrial networks alone can't guarantee. The connection can be blocked by buildings, weaken in low coverage areas, or not exist at all. Luckily, this terrestrial problem has an out-of-this-world solution. Satellites can provide the channels, reach, and ubiquitous connectivity that make 5G possible. The European Space Agency is working with its partners to develop integrated satellite and terrestrial-based 5G services. Space technology can help fill the gaps in ground-based networks, extend reach, improve data protection and reliability, supply the massively increased volume of information required for all the applications that 5G enables, and make 5G part of your everyday. With the help of space, the future of connectivity is closer than you think. To join ESA's Satellite for 5G initiative, visit our website.
So that, I hope it helps in convincing the idea of the integrated set of connectivity, of which satellite is one element of it. Try to address the need of industry and people in different way. And so what we've done at the European Space Agency, we set up an initiative which is called Satellite for 5G Initiative. And the Satellite for 5G Initiative is meant to promote satellite as one of the networks to deliver 5G services. The idea is to support the European and Canadian industry to demonstrate the convergence and integration with the 5G terrestrial technology and satellite to deliver ubiquitous, high throughput, low latency services. So what we're doing is, as part of this initiative, we have a number of work streams, as we call them, one of which is reach out to the terrestrial 5G community, both national and international, in order to help the proliferation of satellite services for 5G. We are also working with the 3GPP standardization and promoting satellite as one of the standards to be part of the next release, release 16 of 5G standardization. And in fact, there was a meeting last week for 3GPP where, for the first time, they recognized and approved new study items aimed at non-terrestrial network as part of the next release of 3GPP. We are working with the European Commission as well. The European Commission is very active in 5G European projects. In fact, the European Commission has set up a public-private partnership called 5G PPP, and is heavily involved in working with European industries, both at national and international level. But again, a lot of those projects with the European Commission are terrestrially based. Satellite is marginally, if at all, present in those projects. So as part of the European Space Agency, we are trying to complement, augment, and integrate those projects from the European Commission and working alongside the European Commission to promote satellite as part of the demonstration and trials that those projects cover. Finally, both independently as part of the European Space Agency and with our partner and with national and international 5G organizations and fora, we are promoting a number of developments, engineering user trials and user pilots to demonstrate, to develop new technology for satellite, but mainly to demonstrate the effectiveness of satellite service delivery for the majority of 5G services. We have our own website, which is called artes.esa.int, satellite 5G. If you simply Google ESA 5G, you will find a lot of information about that. And we have a number of finance projects. We aim at delivering 5G services and solutions even using current satellite technologies or developing new technologies for network involving satellites. As part of the initiative, we assigned a memorandum of understanding with the majority of the satellite operators and industry. There's a list here of the initial signatories of our joint statement. The statement is called 5G Joint Statement. It's a public statement open to everybody to endorse. But the name and the logos here are the initial signatories being part of this joint statement. You probably recognize the majority of the geostationary satellite operators, as well as a lot of the new non-geostationary satellite constellations operators, alongside some of the biggest European satellite prime manufacturers like Airbus and Thales. Since we signed the agreement, more and more companies are joining and endorsing this statement, which effectively states that satellite is very important for the delivery of 5G services, and the satellite community joins together to make sure that satellite is represented in any 5G initiative. Just to give you a flavor of the satellite industry, the global satellite industry is it's a flourishing industry and it's a growing industry, but nevertheless, in terms of size, is very small compared with the large 5G cellular terrestrial operators and 5G network vendors. So although there's something like $260 billion total industry revenue, the global satellite community is a little bit more than like Apple and Amazon together. So if you compare with the big giant, the terrestrial giant, the satellite community in itself is a small niche market. And that's why there's the need for federation of the industry by organizations like the European Space Agency. Okay, a little bit more on 5G use cases and verticals. I think I mentioned a little bit before. In the blue circle, there's a list of the 5G verticals as are defined, vertical markets, which are the markets identified by the 5G terrestrial community. You recognize things like transportation, industry 4.0, utility, and smart housing, and public safety and emergency verticals. On the outer ring, there is a number of use cases which each vertical will address. So there's a wide number of studies being done about 5G verticals and 5G use cases in order to try to derive the requirements that each use case has and try to standardize this set of requirements. Well, we've done a similar exercise with our signatories, the one showed before, and trying to identify where satellite can add more value and where is satellite best suited and where should the European Space Agency invest in industry in order to strengthen the capability of satellite to address the most promising 5G verticals and use cases. And the general result is that satellite already from today addresses a lot of those vertical markets, and in fact even today delivers solutions, non-5G, non-integrated solution, but delivers solutions from today in many of those areas. And if we keep investing in improving the technology and integrating with 5G terrestrial, satellite can be even more effective in those areas. I think all the operators agree that among all the set of verticals in the previous slide, the four main hot markets for satellite are the one listed in the slide here. Besides the classical trunking and backhaul is something the satellite is very good at, which linking up local cells with the rest of the network. So backhaul by satellite means integrating local community back to the rest of the network. A satellite typically is very much used for that, although even for that, recent market studies show that although there is a huge market for 3G, 4G, and 5G satellite backhaul, the current satellite penetration into this market is a little bit more than 2%, meaning that there's a huge potential for the satellite community to continue investing and delivering backhaul solutions. But that's the traditional market. What became very apparent that the other three strong verticals for satellite is first and foremost transport. Transport meaning maritime, satellite communication, aeronautical, aviation communication, and land communication. So there's a huge amount of use cases within the transport vertical markets, which are huge potential for satellite to address either direct satellite to the user, like, for example, delivering communication to planes and to ships, or perhaps indirect communication by means of integration of 5G, picocell, 5G, small cell with satellite. Another two very, very important markets are media and entertainment, which is something typically from the satellite world is called broadcast and multicast. Again, there is a need to deliver a large amount of information to concentrate to where there's a high concentration of people or objects or sensors, or retrieve information from area with a high concentration of sensors. That's where satellite is very, very strong. Satellite can offer efficient, network efficient, and energy efficient solutions for 5G. And finally, the very strong vertical market for satellite is public safety. Public safety meaning all kind of disaster relief, emergency response, civil protection, fire department, police, ambulances, everything to do with keeping the public safe. That's where satellite is very important. In emergency situation, in terms of delivering, fast delivery of 5G picocells enabled by satellite, that's a very, very strong market where most of the satellite operators are actually already actively present, and they want to contribute with the 5G infrastructure delivery. Just as an example on the transport use case, there is a lot of study behind each of these markets, but if you open up the transport, of course, transport covers, as I mentioned, the aviation, maritime, and land mobile community. There are different use cases for 5G for transport. First of all, passenger communications, so delivering high throughput to people on a cruise ship or to people on an airplane. There's a lot of cabin connectivity market for aviation, which will require more and more sophisticated satellite delivery, but also a lot of communication for the machine-to-machine and sensor communications, where there's a continuously growing market where everything moving towards autonomous ships or autonomous aircraft or drones of remoted payload, RPAS and UAVs. That's where we see a very, very growth in market, and delivering of satellite 5G service is going to be of paramount importance in order to address those specific verticals. We're working with some of the big cruise operators or some of the autonomous vessel manufacturers in fleet management. So there's more and more the move towards artificial intelligence and autonomous vessel operation. That's where we see where satellite is going to be very, very important as well, and providing an integrated communication where the shore-to-ship communication will be provided either by terrestrial 5G cellular comms or SATCOM, where 5G cellular is not covered. All of this, I think, I will not dwell too much, but we talked about the software-defined network and virtualization, and of course all those elements and the slicing, the 5G slicing, that's where the technology built into satellite networks continues to evolve in order to provide not only being part of the standard, but being fully integrated in the future 5G networks. So based on last year of Satellite for 5G initiative and working with European and Canadian industry, we identified the need for a European Space Agency to try and help the industry and put not only financial support, but also technical support to federate the satellite community and provide the right access to 5G terrestrial forum. So first and foremost, our role of ESA is to support the satellite, the European and Canadian SATCOM industry. But we also realized that as part of our study on 5G that there is a general lack of awareness in the 5G terrestrial community about satellite and what satellite can do in help to deliver 5G services. So one of our roles is to promote and make sure that there is more awareness in public forum about the role of satellite in 5G. On the flip side, without satellite, the lack of awareness can also cause a risk of segregation because the 5G will be pervasive and will be, as I said before, the fabric connectivity of Industry 4.0. So if satellite not being part of that, there is a risk that it will be even more segregated to deliver just last minute communication rather than being part of the network design from the outset. Also from the socioeconomic impact, there is a risk of unrealized 5G potential. We see that the big promise, the big hype created by 5G terrestrial community might not be so easily delivered, where there is a problem of deployment of 5G cell everywhere, and the network vendors, cellular operators will start concentrating where the big market is, which is in the big cities, perhaps leaving gaps of connectivity. And we looked at some of the NSR report, GSMA reports. We studied the penetration of 3G and 4G and 5G communications in the future. And I think the top right curve's not very clear, but what it shows that even in 2025, there is an expectation that the 5G relative deployment versus other communication like 2G, 3G, or 4G will not be much more than 15% of the relatively to the other type of communication, which means that although everybody talks about 5G, even in 6 or 7 years' time, you will not see a lot of 5G deployment everywhere. You see 5G deployed in a very big city centers. And in some of the country, you can see perhaps 5G deployment 50% in the US, but other countries, like Europe, for example, you'll see more than about 30% deployment of 5G, and other countries like Middle East, America, and perhaps China and Latin America, even less than that. So without satellite, really this promise of ubiquitous and always connected everywhere is going to be a challenge. So it's important not only for the satellite community, but also for the 5G terrestrial community to have satellite as part of this the fabric of connectivity delivery. And said in another way, this is the integration between satellite and terrestrial needs to go hand in hand in order to continue develop the technology roadmap, but also the service delivery roadmap which builds satellite from the outset. So some of the things we are doing, besides increasing the awareness and show the satellite benefits, is also actively participating, as I mentioned before, in the 3GPP standardization bodies to make sure the satellite is part of the 5G standard from the outset. And we continue to support industry to deliver 5G features, being the network function virtualization, the orchestrators, the slicing, and part of the end-to-end 5G service delivery, where the user will not necessarily need to know how the 5G service or application is delivered, but there might be a satellite element in the delivery mechanism. Finally, we are promoting and financially supporting a number of demonstration and tests with industry by and large to have international 5G trials which involve satellite. And we establish a partnership in Europe and outside Europe to do that. And as I mentioned, we work with the European Commission, specifically in Europe, to make sure that there is an institutional coordination between the satellite community and the terrestrial community. I guess to sum up, I hope I made the case that satellite is an important delivery mechanism for 5G, and at the same time, 5G is very important for satellite. I think that there's a mutual win-win situation that, if it's not enabled and fostered, might result in not only satellite being segregated, but also 5G not being able to fulfill the promises that that it makes. So therefore, the satellite integration in 5G is key to success of the industry by and large. You can find the statement that I referred before at this website, or talk to me afterwards. And we want to continue to support the satellite community to flourish, but more importantly, to be part of this revolution that 5G is representing. I think this is the end of my talk. I hope it didn't take too much time. I'd be happy to take any questions if there are, or talk to me afterwards. And thank you very much for your attention. Thank you.
Are there any question?
Yes.
Please.
Thank you, Dr. Magdi. Okay, your presentation is very interesting. So I have two questions. One is, we know that there are three typical applications in 5G, including EMBB, URLC, MMTC. So how do you evaluate the role of satellite in the three applications? This is the first question. The two question is that how do you think about large-scale satellite systems? For example, OneWeb, SpaceX. How do you think about the perspective of the two systems? Thank you.
Okay, thank you. Thank you very much. Thank you for the question. Very relevant questions. Yes, the three fundamental services that 5G promises are indeed the EMBB, the extreme broadband communication, ultra-reliable low-latency communication, URLTC, and machine-to-machine type communications. Indeed, those three fundamental services are already addressed by satellite. We see that the advent of new technology, satellite technology, are actually preparing the future for even further integration and more significant contribution of satellite. For example, the very high throughput satellites, these are the new type of geostationary satellites being built by many operators, are addressing exactly the first of those services, which is EMBB. They will be able to deliver, people have now announced terabit per second satellites over a specific region. So that will go a long way to deliver on the promises of gigabit, or if not terabit satellites, terabit per second via satellite. On the EMBB, machine-to-machine communication, equally, there are a number of studies, and I think University of Rome is part of some of these studies, to improve the efficiency of allowing more more user terminals into the satellite networks. So it's actually preparing to address exactly that aspect. And finally, the last ultra-reliable low-latency communication is an aspect that, of course, satellite, the geostationary satellite is at a disadvantage because of the satellite hope delay. However, the new constellations, like OneWeb and SpaceX, one of the main attributes is to reduce the latency. To get that coupled with the MEC, which is the new technology to push intelligence at the edge of the network, will help minimize, will help to reduce latency, reduce the delay perceived by the user. So we cannot eliminate the satellite delay, that's a physical constraint, but we can improve the user experience by pushing information technology at the edge. And I guess the second part of the question, yes, indeed, we are working with a lot of the new operators, new space operators, specifically with OneWeb. We believe that OneWeb and SpaceX have a big role to play alongside the other satellite in delivering 5G services. OneWeb model, business model, one of the OneWeb business model is predicated on 5G and integration between 5G terrestrial and their delivery services. We're very happy to work with OneWeb and other operators to integrate their constellations into the service delivery. So we believe that that is very important and is fundamental to the delivery of the global 5G services. Thank you for the questions.
So first of all, I would like to thank you. It's really interesting topic. Nowadays, every people, wherever you go, they talk about 5G, and especially satellite should be there, because as you mentioned, 3GPP started new radio for a non-terrestrial network, and definitely satellite will be the solution. But as you know, the satellite communication has its own challenges, especially when we talk about 5G, we talk about wideband, about 3 gigahertz. Yes, 2012 they talk about at least 1 gigahertz, but now they talk about 3 gigahertz, even 5 gigahertz. So the channel estimation will be a problem. High pass loss at millimeter wave will be another problem. Doppler shift and those stuff. I would like to ask you, have you considered this problem? Because when we're moving from microwave frequency to millimeter wave, there are some challenges, especially in high pass loss, and that's why we're going to deploy 5G in a small cell. And the second question, I'm a bit confused because, you know, US and Asian countries, they are going to deploy 28 gigahertz for 5G, and European country, they use 26 gigahertz, because in Europe, we use 28 gigahertz for uplink satellite communication. So are we going to use same frequency band? If yes, so we will have more interference, and then probably we have to use beamforming in satellite communication and make story a bit complex. Or no, we are going to use another frequency band for satellite communication in 5G. And if yes, so we have to consider it for RF equipment. Thank you.
Thank you very much. I think you managed to concentrate in 30 seconds the topic of a workshop which will take a day to answer. However, I will try. Those are very, very relevant questions and are the key of full understanding of 5G. Obviously, you are one of the persons which have a better understanding than others, so I'm very glad to hear that. I will try to give a very brief answer. Yes, there are different ways of delivering 5G, and the different regions around the world have taken different approaches. Our approach is more holistic, and as I was trying to make the point in the presentation, we are more interested in delivering of 5G services rather than necessarily the technology involved to deliver those services. So yes, there is identification of millimeter wave, both terrestrially and typical satellite band to deliver those services. The satellite operators are already using some of those bands, like the Ka band, as we call it, which is the 20-30 gigahertz, and others. My point is that here there are other bands, also lower frequency band, like the 1.5, 2.5, 3 gigahertz, but also the very high frequency, what we call QV band, 60, 70 gigahertz, and moving into the laser communication, we have a program of optical communications, which will also be able to deliver very, very high throughput services, which will contribute to the 5G. So there is a different approach between the type of technology and the frequency and the range of network to deliver. Specifically on your interference and coordination, that is indeed a very, very interesting topic to address. There's no doubt going to be the need of having a proper access to spectrum, some of the common spectrum between terrestrial and satellite. There's a very, very interesting area, as you mentioned, of not only beamforming, but the dynamic resource management and spectrum management in order to optimize. We heard this morning about minimizing energy efficiency, but they're complete different, but perhaps similar operating research problem to optimize the delivery of information by means of satellite and terrestrial communication, perhaps utilizing the same spectrum at some point, either by geographic separation or beamforming or interference mitigation and cancellation techniques, which will help the coexistence of different methods using the same frequency. And this is an area of research and not all, shared by everybody globally, but I think we are trying to promote the investigation of areas where some of the frequency can be reused, used at the same time, or used efficiently and intelligently between terrestrial and satellite operator. But my point is that that's not only the point of concentration. We can make use of the entire satellite frequency spectrum from the 1 megahertz up to the laser communication in order to deliver 5G services as well. Thank you.
Thanks for the presentation. Actually, it's not my field of study, but I have a question. I think if we want to communicate with the satellite, we have a low bitrate channel, so it's better to use for sending control packets, like a small packets like control packets, instead of sending big data packets to the satellite. So isn't it better to use the satellite as a manager to, for instance, manage the system instead of involving it for connectivity or these kind of stuff? So it can be at the top and manage everything instead of involving in sending data packets. Thanks.
Okay, thank you. Yes, that's another element of this complex problem we were trying to articulate. Indeed, in some cases, it might make sense to have a control plane, as you meant, delivered by satellite, and a user plane by terrestrial communication. It depends on the market, it depends on the applications, it depends on the user, whether the user is an individual or whether it's a factory or whether it's an industry, depend on the access to energy sources and the amount of the size of the user terminal devices needed. But it is certainly a possibility which is already being used in many areas where perhaps the control channel, which require much lower throughput, but perhaps more resilience and more availability and delivery assurance, can be done by satellite, which is intrinsically a more resilient network, and then the remaining user communication can be done terrestrially if there is availability of terrestrial link, of course. If you're talking about delivering command and control to an unmanned aerial vehicle on the desert, then there is not terrestrial communication. So you will have a very high reliable command and control link, perhaps with a low frequency satellite control link, and then a very high throughput satellite link for the delivery of images taken by the UAVs. So it depends a lot, but yes, in general, it is possible to have a hybrid network where there is a control channel by satellite and a user plane by terrestrial. So that's certainly one of the areas that will be integrated, and it will require frequency coordination and inter-network coordination embedded into the network orchestration. So it's very relevant for 5G.
Just a short last question, and then
Sure.
everyone can meet the speaker during the break.
Thank you for presentation. In the last slide, you talked about satellite and terrestrial. What about the opinion in the delay between terrestrial and satellite in 5G?
Yeah, thank you. Yeah, we touched a little bit upon delay. Yes, the satellite network inherently different delay or latency from terrestrial network. Depending on the application, a lot of the machine-to-machine or sensor communication, they are delay tolerant, which means that they can tolerate different type of delays. Although one of the promise of URLTC, as mentioned before, some terrestrial advertisement talk about less than a 1 millisecond delay for 5G. We believe this is a big hype, and it might be true for perhaps online surgery or something where the latency is very, very important, but the majority of the applications will require a more relaxed type of latency. So in that case, in that respect, satellite can be part of the delivery, part of the solution, but there will need to be synchronization between terrestrial delivery and satellite delivery. And again, talking about satellite, it was mentioned before, not all satellites have the same latency problem. Geostationary satellites have a certain type of latency in the order of hundreds of milliseconds. Low Earth orbit satellites have latency in the order of tens of milliseconds, which for the majority of the ground network, the low Earth orbit satellite delay are actually better, lower than some terrestrial network. So in that case, the low Earth orbit satellite constellations can provide better delays, less delay than a lot of the terrestrial network. So obviously, latency is an important factor to consider in the delivery of solutions, and it needs to be addressed on a case-by-case basis. But satellite can and will play a big part in a lot of these applications, except for the application which require less than 1 or 5 milliseconds delay.
Okay, thank you. Thank you, Antonio Franchi.
Thank you very much.
As for all the keynote speakers, there is...
Thank you very much. Thank you. Thank you.
Thank you.
Thank you to the speakers, and they also for being on time. We are more or less on time with respect to schedule. Now we deserve lunch, and just to reduce 10 minutes the time foreseen for lunch, so we have 1 hour.